positive integers, what is the unit digit of 8 to the p plus 7 plus 4 times r? The question states that p and r are positive integers and they want to know the unit digits of this power. So first of all, is there a way to find the unit digits of the powers of 8? So, in order to find the unit digits of 8, of the powers of 8, we can do the following. Eight to the first power, a. 8 squared is 64, but we're going to focus only in the unit digits. Then we get that 8 cubed has a unit digit of 2, and 8 to the fourth power has a unit digit of 6. 8 to the fifth power has a unit digit of 8. 8 to the sixth power has a unit digit of 4. 8 to the seventh power has a unit digit of 2, and 8 to the eighth power has a unit digit of 6. Therefore, 8 to any multiple of 4 has always a unit digit of 6. Now, with this information, we can have a look at statement 1 alone. P equals 5, therefore, we have 8 to the 5 plus 7 plus 4 times r. And this is 8 to the 12 plus 4 times r. And this is 12 is a multiple of 4. And 4 times r is another multiple of 4. Finally, the sum of two multiples of 4 is another multiple of 4. Finally, we get that this power is the same as 8 to a multiple of 4. Therefore, the unit digits of this power must be 6. Statement 1 alone is sufficient. Alternatives B, C, and E are eliminated. Now, from statement 2 alone, R is 100. We have 8 to the P plus 7 plus 4 times 100. This is 8 to the P plus 7 plus 400. And finally we get that this power is equal to 8 to the P plus 407. Since we don't know the value of P, we don't know in where row this power is gonna lie. So the unit digits of this power can be either 8, 4, 2, or 6. Everything depends on the value of P, but we don't know the value of P. Therefore, statement 2 alone is not sufficient. Alternative D is eliminated. Choice A is correct. If m is a positive odd integer, what is the remainder when m is divided by 6? The question still states that m is a odd positive integer, and they want to know what is the remainder when m is divided by 6. From statement 1 alone, when m is divided by 12, the remainder is 9. So I can write this sentence like this: m is a multiple of 12 plus 9. Now, is a multiple of 12 also a multiple of 6? Remember that any multiple of 12 is a multiple of 6 as well, since 12 is a multiple of 6. So I can write m like m is a multiple of 6 plus 9, and 9 can be written as 6 plus 3. A multiple of 6 plus 3 plus 6 is another multiple of 6. But therefore m is a multiple of 6 plus 3. Finally, the remainder when m is divided by 6 is always 3. Statement 1 alone is sufficient. Therefore, alternatives B, C, and E are eliminated. Now, from statement 2 alone, m is w times w plus 1, where w is an integer. If w is an integer, the product of two consecutive integers is always even. Therefore, m is an even number plus 1. An even number plus 1 is odd. M is an odd integer. But remember that the question team said that m is an odd integer, and that really helped us to find the answer. So statement 2 alone is not sufficient. Alternative D is eliminated, and choice A is correct. If r times s is not 0, is r over s less than 0? The question still states that neither r nor s are 0, and they want to know whether this quotient is a negative number or not. So from statement 1, r times s to the 4th power is a negative number. Therefore, r must be a negative number. However, we don't know anything about s. S might be either positive or negative. So, statement 1 alone is not sufficient. Alternative A and D are eliminated. From statement 2, r to the 4th power times s is a positive number. Therefore, s must be a positive number. However, we don't know anything about r. R might be either positive or negative. So statement 2 alone is not sufficient. Therefore, alternative B is eliminated. Now we need to use both statements together. From 1 and 2, r is a negative number and s is a positive number. Therefore, the quotient r over s must be less than 0. Now, statement 1 and 2 together are sufficient to answer the question. Therefore, alternative E is eliminated, and choice C is correct.